Hello and welcome to today's lesson on chi-square test for independence. So our objective today, by the end of this lesson, I will understand how to conduct a chi-square test for independence and why they are important. Okay, always starting with the why. A chi-square test for independence tells us if we have two categorical variables that we're looking at, and we want to find out whether they're independent or dependent, this is the test that we would want to do. If you only have two categories on each side, you could do this as a proportional test, but the chi-square test is a quicker, faster process for getting the same result. So what we're going to look at today is a person's age independent from their preferred choice of social media. So now, we always start with the first thing. Can we trust our answer? What are the assumptions or conditions that we have to test? The good news, chi-square never changes. Our assumptions are only two: simple random sample of values and our expected counts. Okay, remember it has to be your expected table. All expected counts at least 5. Okay, so make sure that as a part of your process for the problem, you show your expected value table, because that will be the verification you need for the assumptions. Just a reminder about the chi-square distribution. It's not a normal distribution. It always starts at 0, okay, and works off from there. So your chi-square values are going to be larger values than your z's and t's in a lot of cases. And we're always looking at an upper tail shading. So whatever chi-square value you find, that is your lower boundary when you're doing your CDF and solving problems for the probability. Okay, our hypothesis statements. Just like in the goodness of fist chi-square test, it is just a statement. Okay, your null statement is that your two categories, whatever their headings are independent of each other. So for us, a person's preferred social media choice is independent of their age or on their age. And the alternative, a person's preferred social media choice is dependent. Okay, so there's only a one-word difference between your null and alternative hypothesis in this situation. Okay, now calculations. Calculations in this situation take a little bit longer overall. We're still using the exact same chi-squared formula. Okay, so if we're going to go through, we're going to show some of these calculations overall. But the good news is when we get to a test like this with a lot of data, instead of doing 12 individual calculations, we'll let the calculator do a lot of the work for us. Okay, now, how do we get our expected table? We knew in the one-way table we had percentage values. We use those percentages to get our expected value, and there really is no difference here. It just takes us a little bit longer to get our percentage values. So the first thing that we have to do is add and get what we call our marginal distribution. Okay, so it's all of our total values for every row and every column. So we add the values up, get all of our individuals, and then we have the total of the entire table, 475. Okay, now, once we have that, we just need to know what proportion are we working with. Now, if this is an independent situation, okay, it is going to be distributed based on these values out of the 475. So we want to turn these into percentages. 211 out of 475 is 44.4%. And then we move on to our next age category. 151 out of 475 is 31.8%. And then our last category, 113 out of 475 equals 0.238. Okay, now, once we had the percentages or the equal distribution in our goodness of fit test, we had to multiply that by a total value. And it's no different here. So when we're looking at just Facebook, we know that Facebook has 223 individuals overall. That's the total. And we have our proportional breakdown over here on the right-hand side, okay, for multiplying that out. So if we do our percentage times the 223, okay, we get an expected value for Facebook of 99.1. And then we do the 0.318 times the 223 to get our expected value for 30 to 49-year-olds that chose Facebook. Okay, and then we work through and finish out the rest of the table. Okay, now, in an individual problem, you're not going to have to do all of these by hand. You're going to be able to have the calculator find the table for you. But what you are going to have to do is be able to figure out how to find any individual value. That's a very common multiple choice question on the AP exam. And as I finish out the table here, we can start looking at our next step. So now, how do you get each individual value? If I want to find this value, the expected value for 18 to 29-year-olds that picked Instagram, what I'm looking at is I'm looking at the proportion of the overall population that is in the 18 to 29-year-old range and multiplying that times the total value for the Instagram row of 89. So that's how I get that individual value. Okay, let's take a look at just one more and show you how we get an individual expected value. I want Pinterest for the 30 to 49-year-olds. Okay, I need the 30 to 49-year-old proportion, okay, for that category, and then I'm going to multiply it times the total to get that value. Okay, now, for our expected value work, okay, we have to use our chi-squared formula. Now, we don't have to do all of it, but you do have to show that you understand how the formula works in solving a situation. So for our chi-squared value, it's always observed minus expected squared divided by expected. And then another value, usually all you would have to do is show that you understand that there is the addition pattern and that you can construct the formula values correctly. And then we just go dot, 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 and we'll let the calculator do the rest of the work for us. Okay, now a couple notes as we're finishing this up. Degrees of freedom. Remember, it's how many values do you have a chance of manipulating? And when we're looking at a table like this, if I look at the 18 to 29-year-olds, I can manipulate these first three columns, but then Pinterest becomes locked in. Okay, so I can't do anything with the Pinterest column. Now, when I look down, I can manipulate the first two columns, but then this last category becomes locked in. So the area that I have freedom in are these inner 6 values. And that's where the rows minus 1 times columns minus 1 comes from. Okay, you're eliminating one category from your columns, or eliminating one category from your rows, and then the number of values are left are the ones that you have your degrees of freedom with. Okay, now, we said that we're going to use the calculator to help us with that overall. So let's just start back at the main screen. Okay, we can find almost any test we need in the stat test heading. Okay, so if we scroll up is actually the quickest way to get there. There are two chi-square tests. The goodness of fit is for that one-way table, one category, and that's actually almost better to do by hand than try to set up everything for that formula. But the chi-squared test for independence is nice. If we open up, we can see what we need for those values. To do this chi-squared test for independence, we need a matrix A. Now, it talks about the expected matrix B. The good news is the calculator makes that for us, so we don't have to do anything else work-wise. So now, to get to your matrix screen, it's second and then the inverse button gets you into your matrices. We have to arrow over to the edit, and I already have this matrix edited in. Okay, but let's take a look at that. And then you want to hit enter once you get to the edit. First thing that you have to do is describe your size. So this is a 3 by 4 matrix. So 3 enter, 4 enter. And then you just go through and enter your individual data values. Okay, fill in the table overall. Always double check your entries to make sure that you've entered them all incorrectly. That's the number one mistake that happens in a lot of these problems is an entry mistake. So now, once we have it entered, we go back to stat, test, chi-squared test, and we select. So now we've got our observed matrix in A. It will build the expected matrix for us in B. And then we just have to enter, enter, enter to finish up. So now we've got our chi-squared value, so we can finish out this calculation. Didn't have to do it by hand. Okay, letting technology help us with that. It also gives us our p-value, so all we have to do is write our probability statement. You know, the probability that our chi-squared value is greater than 18.03 equals 0.006. And then it also gives us our degrees of freedom as a reminder of that. Okay, now, like I talked about before, in the assumptions, you have to list your entire expected matrix. So if we go back into our matrices, now we notice that B has a matrix in it, and if you just hit enter twice, okay, it gives you your expected values for the matrix. We usually just round to 1 decimal place, even though the calculator will show us more. Okay, so now we've verified our assumptions, we've done our null and alternative hypothesis, we've finished our calculations, and then every problem finishes up with the same thing, our conclusion. Okay, remember, you always have to state your evidence. Probability value of 0.006, less than a 0.05 significance level. What conclusion do you make about the null hypothesis? In this case, we're rejecting it. And then we have to make a statement about the alternative. This evidence supports the alternative that a person's preferred social media choice is dependent on their age. Okay, so now for homework today, we always have our Schoology quiz. So you've got your Schoology quiz on chi-squared test for independence, and then also for your in-class packet, you have problems 6 through 11 for additional practice. Thank you and have a good day.